Hi everyone, so this is the Unit 1 review. I will go through as much of this as I can. So here we go. These are all questions related to the fact that congruent parts of a polygon can map. And a lot of these questions show up on the regions all the time. So this question is a reflection over which line does not. Always pay attention to those not questions because I like to put them on there. Okay. We need to be able to graph all of these to truly understand it. So y equals x, as a reminder, what I'm talking about choice 3 right now, is the line that goes diagonally in a positive direction through the origin. If we think about it, this is a square that will definitely fold onto itself from there. Okay, it's almost as if you were literally folding it over. And feel free to do that on the test if it makes more sense to you. Like, try to actually physically pick that paper up and fold it and say, okay, yeah, that'll definitely fold. We're going to leave that one for the end. Y equals 2. So you go to the y-axis, there's y equals 2, and it's going to cross through that. Okay, so again, symmetrically, I'm even on top and bottom. That will definitely fold over that line, so it's not that one. And then x equals 5. 1, 2, 3, 4, 5. This one is on the edge of a square. It's not going to fold onto itself. It's going to fold all the way over there. So x equals 5 is the correct answer for this. Now I said we're going to leave this till the end. Say this was the answer. You would have to rewrite it with y by itself. This is your y-intercept. This is your slope, which is -1/1. So this is starting at positive 4, and then it's going down 1, right 1, down 1, right 1. So if you notice, it's that other diagonal through the square. But luckily for this one, you wouldn't have had to go that far as long as you know your x and y lines. Which regular polygon has a minimum rotation of 45 degrees to carry it onto itself? This again is a very popular question. So anytime you see this, you're going to do 360 because that's always your rotation degree that you start with, and you're going to divide it by 45. Okay, that's going to be 8. In this case, it's asking for a shape, and an octagon is a shape that has 8 sides. Which rotation about its center will carry a regular decagon onto itself? Okay, so this is a similar kind of a question. A decagon has 10 sides, so it's 360 divided by 10, which is 36. You'll notice 36 is not one of the answers. Take a deep breath, that is okay. You can turn it 36 degrees however many times you need to. So 36 times 2 is definitely not 54. You basically go through each one and see which is a 36 is a factor of. So if you go through here, 252 divided by 36 is 7. That means that that's a good answer. So it's 252 degrees. Versus, just to show you, 162 divided by 36 is a fraction. It's not an integer. And that's how you know that that is not the correct answer. Next one, we're going to construct an equilateral triangle inscribed in the circle. So whenever you're inscribing anything in a circle, I encourage you to start with a diameter or a radius. We've done this a few different ways. Okay, so you start there. You then measure your radius, not your diameter, but your radius. And then this is where we went round and round and round. So there's 1, 2, 3. Remember, you can move the paper. I'm just not moving it as much because the camera's already struggling to be in focus with my hand moving, let alone the paper moving. And then I'm back. It should fall just right on it. If it's slightly off, that's okay. If it's really off, check it, see if you have a sharp pencil. You can see that mine is not. Ask for a new compass if you need to. We will bring you a new one. Then what you're going to do is you're going to connect every other dot. So 1, 2, and then 3. That would be your equilateral triangle. If they had asked for a hexagon, it would be the same construction and you would connect every one. Okay. A regular hexagon. Hexagon has 6 sides. Yes, you need to know that. Is rotated in a counterclockwise direction about its center. Determine and state the minimum number of degrees in the rotation such that the hexagon will coincide with itself. So I'm hoping that this jumped right into your head because it's that same question again. So 360 divided by 6 is 60 degrees. And that's it for that question. All right. This is all related to CPCTC. As a reminder, this is CPCTC if this word was triangle, but it's saying polygon, so it's saying it doesn't have to be a triangle, it can be any shape. So given these two triangles are congruent, which statement is not always true? Please remember that if there's no picture, the order of the letters are what's going to help you here. So segment BC and segment DF. BC, DF. Nope, BC are the last two. DF should be the last two, so this is not a true statement, which is what I'm looking for. If we look through the rest, you'll see angle A is congruent to angle D. That checks out. Areas should be equal if the triangles are equal, and perimeters should be equal if the triangles are equal. So choice 1 is the only logical choice. The next question. What's going to map figure 1 onto figure 2, then 2 to 3? Order matters here, so make sure you realize, okay, 1's going to 2, and then 2's going to 3. Orientation is what's going to help. As a reminder, anytime the orientation changes, which is the order of the letters, that's definitely a reflection. If it didn't change, it's one of the other ones. Okay. As I can see, A, B, C, everything just kind of slid up. So the first thing that happened is a translation. So 1 and 2 are out because it definitely slid first. From there, it either flipped or turned down. And this is what I'm talking about. If I start at A and go this way, I read A, B, C, D, E, F. If I start here and go this way, I read it in the same order. That tells me it was a rotation, not a reflection. If I had read the letters in any different order, it would have been a reflection. Okay, which transformation of segment OA, I don't know why it printed out down there, but would result in an image parallel to segment OA? So what is going to make this parallel? Think about this logically. If you reflected it, not parallel. If you rotated it, so we turn it this way, not parallel. Translation and dilation are the two that will always keep something parallel to its pre-image. So translation is the correct answer there. Which point shown in the graph is the image of P after a counterclockwise, so that's to the left, rotation of 90. So P is where I'm starting. I encourage you to physically turn your paper to the left, 1 turn. So I'm turning it to the left 1 turn. P is now to the right and up, about 1 and maybe 4 as an estimate. So now that I did that, it's clear to see that it's definitely point A. So that was point A. In question 5, a sequence of transformation maps the rectangle ABCD onto A double prime, etc., as shown in diagram below. That double prime is important because it tells us we started here, we went here, and then we ended here. So 1, 2, 3. Again, that sequence is important. So they're trying to figure out what happened first, a reflection or a translation. Let's start there. So if we look, it could have slid down, but if we focus on the letters, do you see how B is in the top right, but no longer in the top right here? That's because it flipped over. So it started with a reflection, not a translation. And then because the rectangle turns, it's now up and down instead of being left and right, it was a rotation, not a translation that occurred. As a reminder, a translation is a slide. It would always remain, let's say I slid it over there, it would always remain the same parallel to what it was before. Triangle ABC and triangle DEF are graphed on the axes below, which are on the next page. Which sequence of transformations maps the triangle ABC onto DEF? Again, pay attention to the order. So this one is going to that one. Pay attention to the order of the letters. That's going to help me. Before I even read this, I'm not quite sure if it's a reflection or a rotation. So ABC. So A left to B to C. Okay. Do I go D to the left? No, I go to the right. So that means a reflection happened because the orientation is different. So it's not a rotation. It's not a rotation. And then I just reread this one to make sure. Nope, it's definitely a reflection. Okay, so, oops. And then I always double check. Always double check. Okay, a reflection followed by a reflection. That's 2 reflections. A rotation followed by a reflection. Rotation followed by a reflection. Translation, rotation, that one's definitely out. Okay, a reflection. So if you look at the ruler really quick, just to show you an example. If I reflect it and then I reflect it again, notice I end up back where I was kind of. So two reflections almost work like a rotation of 180 degrees when it's an X and a Y axis. So that one is actually out. So it's a good thing I always go back and reread my choices and make sure I'm okay. So 180 degree or a 90 degree rotation followed by a reflection over one of these two. So now I'm going to physically do these out to see which one it is. So I'm going to try 3 first. So a rotation of 90. So I turn my paper to the left 1 turn. Notice that A is now at 2, -2. So I'm going to put it back and draw that. So if this is A prime, and A needs to get to D, because again, the first letter matches the first letter, that now just has to flip over the x-axis. Ooh, not the y-axis. Okay, let's check the other one, 180 degree rotation. So this one's gonna turn to the left twice, so I'm looking at it upside down. A is now at 2, +2. So if I put A up here at 1, 2, 1, 2, D is on that. Okay, so that's kind of good news so far. So that's a that's A prime right now. Let's go with C. So I flip that over again, or excuse me, I rotate it. 1, 1, 2, 3, 4, 5, 6. I plot that. 1, 1, 2, 3, 4, 5, 6. Okay. And then I have, so C went to F. Did I do the order of the letters wrong? Well, we're about to find out. Okay. This is, again, a good thing, multiple choices there. It's good problem solving. So, I might go back to my original statement here. B, I'm going to rotate it 180. So B is at 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, so I just didn't pay attention to my orientation well enough. 1 was in fact the correct answer. I did it right to begin with. Because remember I said X and Y axis, that's the same as 180. Well, I just proved myself there that I did it correctly. So now I just want to check here. A, B, C, I went to the left. Oh yeah, I just I just don't know my left and right, circular. So it's a circular left and right, so that's why. There we go. I could have gotten it 5 minutes ago, but at least you saw the actual going through each one and eliminating from there. Okay. Quadrilateral ABCD is graphed on the set of axes below. There it is. When it's rotated 90 degrees in a counterclockwise direction, its image is that one. Is distance preserved under this rotation? So remember, dilation is the only thing that doesn't preserve distance. So the first question is a yes, factually, 1000%. Okay. The next questions, which one is for the given vertex? So we have to look at A and B. Again, I'm just going to physically turn my paper to the left 1 turn. So there's my turn to the left. B's coordinates are -3, +4. Hey, there it is. A's coordinates are -6, -2, which is not +6, +2. So that's how I would get that one. The next question shows us a rectangle ABCD to KLMN. So again, I'm going to see how they map. So K maps to A by flipping, D maps to N, I maps to B. So let's just check this. D to N, that's good. B to L, that's good. So this was definitely a reflection over the x-axis. And if not, you could go through and test each one like I did in a previous example if you weren't as confident as I wasn't on that one, but then figured it out. Triangle ABC is graphed on the set of axes below. Graph and label the image of the triangle after reflection over the line x equals 1. So the first things first, x-axis, that's x equals 1. That line has to cross the x-axis, so it's a vertical line. And now we just count. So B is 1 away, so it goes 1 away in the other direction. C, same thing. And A, same thing. And then make sure you use your straight edge to connect them all. Okay. And label, label, label. Do not forget to label. Using a compass and a straight edge, construct the line of reflection. When in doubt, bisect, people. Over which triangle RST reflects to the other one. Okay, so now when I'm saying when in doubt, bisect, that's always a good example. But just think about it logically. A line of reflection falls in the middle. So if you focus on two pairs, like R and R prime or T and T prime, and you do, oops, moved my hand there. You do the more than halfway construction. And you connect it. That is a line of reflection. Put arrows on it because it did in fact say line of reflection. And I'm done. Describe a sequence of transformations that will map triangle ABC to DEF. Okay, so here are my pictures. Now really it's up to you how you do this. And you can say more than two. Some people think that you're only allowed to say two. No, you can say as many as you want. I try to always start with like a reflection or a rotation and end with a translation, but you can do it any way you want to. Remember, A has to end up at D, C has to end up at F, and if you're ever unsure, you just come back to here in the order of those letters. So A with D, B with E, and C with F. I'm going to choose to first reflect over the x-axis. So that would be my first thing, and I would draw that out to help myself. 3, 1, 2, 3. So here's A prime. Here is B prime. And then C prime is left and down 3, so there's C prime. Now I'm just sketching this right now, so that's why I'm not using a ruler. This is just my work to show what's going on. Now I'm hoping you can see that I just need to slide everything over. So A, B, and C map to their corresponding letters. So I'm going to count 1, 2, 3, 4, 5, 6. A slide is a translation. To the right. What did I just say? 5? 1, 2, 3, 4, 5, 6. Good thing I double checked. 1, 2, 3, 4, 5, 6. To the right, 6. Boom. And I would be done. Now, you might have rotated, then reflected, then did all this other stuff. As long as this triangle ends up on this triangle appropriately, you will be correct. In the next diagram, triangle ABC has the coordinates given. Graph and label the image after a translation 5 to the right and 2 units up, followed by a reflection over the line y equals 0. So it has been graphed for us. Now you can either do your rules to this. So the rules for this would be 5 to the right would be adding 5 to all of your x values. So 4 plus 5 is 9. 4 plus 5 is 9. 1 plus 5 is 6. And then 2 up is adding 2 to the y. So 1 plus 2, 1 plus 2, and 5 plus 2. So that's where I got all of those from. Now the line y equals 0, we have to figure out which axis that is to be able to do this, okay? But basically it means you're just reflecting over y being 0. So here's your y-axis. Here is 0. It's actually the x-axis. That is the line y equals 0 for the record. So when you reflect over the x-axis, everything moves up and down. So it's actually the y value that becomes negative. So this would be 6, negative 3, 4, negative 1, and 4, negative 5. Then you could graph those 3 points. The way to do it out physically, what is it, 5 to the right and up 2? So 1, 2, 3, 4, 5, 1, 2. There's A prime. 1, 2, 3, 4, 5, 1, 2. There's B prime, and then 1, 2, 3, 1, 2, 3, 4, 5, 1, 2. There's C prime, and then I should use a straight edge for that, because this work is being graded on the graph. It's not an optional graph for work. It's a factual graph for grades. Okay. Now, again, you have to understand that this is the line y equals 0. It's the x-axis. So then we go 1, 2, 3. 1, 2, 3. There's B double prime. So there's A double prime. And then C double prime is 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. And there's C double prime. And I don't remember if it just said graph and label or also state the coordinates. We already did state the coordinates a moment ago, but if you were doing it the graphic way, graph and label. Okay, yep. So we did graph and label, but it's always a good idea to write down your coordinates for all of those, which we did on the other page. But if you did it graphically, I would finish. The graph below shows triangle ABC and its image. Describe a sequence of rigid motions that would map triangle ABC onto the other. Again, just start going through it. So I see that a reflection had to have happened because B has to make it over there, so it had to have flipped. So I would start with a reflection over the y-axis, followed by, so B would end up 1, 2, 3, 4, 5, 6. Let me try to count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So B would end up right there. So as you can see, it's just underneath where it needs to go. But I also just caught a mistake that I was making. I need to go that way because this is B and this is B double prime. So B would actually end up over here and then needs to go down 2. So followed by a translation down 2. I have to stop this video here now. I'll pick up the next one on question 14. Have a good day.